My name is Manfred Helber. I'm Microsoft Most Valuable Professional in the category Cloud and Data Center. If you know a few things about how to add nodes and disks to your Azure Stack HCI cluster, you will realize it's not so complicated to do this because Azure Stack HCI is designed to be able and aware of adding disk drives. There are some requirements when you add additional drives, and you have to know a little bit about how Azure Stack HCI stores the data, but it's no problem to add additional drives to add additional capacity. If you have seen the video module about Azure Stack HCI hardware requirements, you already know how Storage Spaces Direct in Azure Stack HCI distributes the data across the drives and across the servers. But I want to recap this very important topic to ensure that everybody in this video knows how this works. Because when we are creating volumes, then Storage Spaces Direct in Azure Stack HCI distributes these volumes in splitting of the volume in slabs or extents with a size of 256 megabyte. These pieces are called slabs or extents. It's the same mechanism we also have in Storage Spaces Direct in Windows Server. These extents are distributed across the servers, and for each extent there are created copies. So if we have an original slab or extent, in a two-way mirror we have an additional copy. Please be aware exactly this animation is not supported for production, because in a three-way mirror, you already know from the volume management video, we only have the three-way mirror on 3 servers. There is no two-way mirror there available. You can configure it manually, but it's not supported. It's absolutely not recommended. So this is the reason why in Windows Admin Center it's not displayed the two-way mirror. Here, the two-way mirror is in the animation because it's easier to understand how the workflow works. And I think you can imagine at another color, let's add a yellow or green, then we could have another copy for the three-way mirror. Because we have the slabs or extents, it's very easy to add drives or even servers and bring this additional capacity to our storage pool. And this then also can be used for our volumes because the slabs are redistributed. This is done automatically. We can have a rebalancing manually via PowerShell in typing optimize storage pool and then the friendly name, and then the optimization starts. But you have to care a little bit about the drive symmetry. We have already discussed the drive symmetry requirements when we talked about the hardware requirements in the hardware requirements video. But to recap this, it's important that all servers should have the same types of drives, the same number of drives. So if we add 2 hard disk drives to each server, and we will do this later in our live demo, we have to add 2 drives in each server. When we add the drives to one server, we have to add the drives in each server. 2 drives or 4 drives, or it's also possible to add 1 or 3 drives, but it depends on the initial storage layout. So we have some binding between cache drives and hard disk drives. If we have, for example, 2 cache drives and 4 capacity drives, the capacity drives can also be flash drives, then we should add 2 or 4 or 6 capacity drives additionally, or 8 or 10. When we have 3 cache drives, we can add 3 or 6 or 9, so multiples of 3, multiples of the number of the cache drives we have, to ensure that we have always a symmetric layout. For sure, if you add drives in a later time, maybe you will not be able to get the same model with the same firmware and the same capacity. It's recommended to use the same drive, But if you have a different model, a different firmware, but the same type of drive, then it will work and it will be supported. If you have a new drive with more capacity, you will have the situation that you may see some stranded capacity. So it may happen that you add capacity where you will not be able to use this additional capacity. We can see such a stranded scenario here. Here we have server 1 and server 2, and in server 3 the situation changes. So additional drives are added or larger drives are added, but we cannot use this additional capacity because of the stranding situation. And what I mentioned, it's okay to have identical type of drives, so in each server NVMEs, but different models. We can see model X and we can see the model Y or model Z. So these are NVMEs here. And here we can see a configuration with SSDs where the cache drives are identical, but we have different types of hard disk drives. But in each server, in the second example, we have 10 hard disk drives. This means identical storage layout. What's not supported to say, okay, I have 2 servers with SSD. Now the NVMEs are cheap. I add a server with the same number of capacity drives, but now with NVMEs instead of SSDs. This is not supported. So you have to decide to use server 1 also with SSDs or to run server 2 and 3 with NVMEs or upgrade them to NVMEs. And it's also not possible to say, okay, we have 2 servers with 2 NVMe drives. The new one will have 4 NVMe drives. This is not supported here. So same type of drives in every server, NVMe, SSD, required. Same number, absolute same number, required. Same drive model in every server is recommended, but not required. Same drive size in every server is also recommended, but not strictly required. Okay, let's check this out. Let's use a demo environment to see how we can add drives to an Azure Stack HCI cluster. Before you add drives to a cluster, you should check his health. So you should have a look at the cluster if everything is fine. I will go to my Azure Stack HCI cluster 40. It's a 4-node Azure Stack HCI cluster. And the first view is in the dashboard. The dashboard is actually loaded. There should be no warnings, no errors, no running storage jobs. Here I can see there's a warning. It's 10 minutes ago. The storage pool is running out of capacity. Okay, maybe this is the reason why I'm adding drives. So this is a warning when I'm looking at, this is the reason why I'm doing this job or this extension. This warning here is actually a small bug in Windows Admin Center. So actually Windows Admin Center in the version I'm using here often displays this error, but we don't have any issues here. We will check this in a few seconds. So the servers are healthy, everything is fine. So let's check the servers. Servers are up and running. Everything is fine here. Capacity is there. Let's check the drives. The drives we can see inventory. And here we can see the drives are all up and running. And they are actually storage in usage something like 70%, 73, 72% is in use. So we have still some free space. In the summary, remember I explained this thing with the reserve we have here. The reserve is still there, so we didn't consume reserve capacity for the volumes, but there's only little space left. So now we should care about expanding our capacity to be able to create new volumes. If I now create a volume, I will consume reserve capacity. If the volume is larger than this capacity here, maybe I should demonstrate this again, because maybe you are thinking, okay, well, why is he not creating a new volume or extending an existing volume? Let's create a new volume, and let's create a 4 terabyte three-way mirror volume. Capacity should be enough there. Let's see what happens. The volume is created. Now it's still creating the volume. So it's creating, storage spaces direct is creating the volume here. Now the volume is successfully created. When I refresh the list, I will see the volume here. Now let's check the drives. And here now we can see I'm consuming the reserve capacity here, or parts of the reserve capacity. In the inventory, I can see, oh, the drives are now nearly 90% in use, storage capacity, because I have created a volume with fixed size. So the volume consumes the capacity when I create the volume. So it's not a good idea to consume the reserve capacity, but I explained to you when we worked with the volumes, when we had the video about the volumes, I explained to you that this can happen because the reserve is not an policy that reserves the capacity. It's only a recommendation to ensure that we don't consume the reserve. Why it's a recommendation? When we have the reserve, we can have a local parallelly rebuild. This means if a drive fails, Storage Spaces Direct rebuilds the lost blocks, the lost extents, the lost slabs with the remaining reserve capacity on the still working drives. So if we have a reserve capacity in the servers, we can have a local parallel rebuild. And this local parallel rebuild will rebuild the full redundancy, even if we don't replace the drive immediately. And because it works on all the drives with some free capacity, it's very, very fast, this local parallel rebuild. So now let's add some drives to the servers. As you remember from the deployment modules, I am using virtual machines as my nodes for Azure Stack HCI. It's easy to build a demo environment for Azure Stack HCI with virtual machines. It's easy to test with them. You can run this on a powerful workstation or powerful laptop or in the cloud, wherever you want. And you can add drives very easy. In a physical environment, you would now need physical drives to add these physical drives to each server. So let's check again how many drives each server has. We have 16 drives overall, so 16 drives in the pool. And this means when we sort here by server, we can see in each server 4 drives. 4 in the first one, 4 in the second one, 4 in the third one, and 4 in the last one. So now I will add drives in executing a PowerShell script. I already prepared this script here. This is my script for adding hard disk drives. I will add 2 of them to each server. I will use the same size, 4 terabyte. My actual drives are 4 terabyte. And I will add this to node 41. So my Azure Stack HCI node 41, this is my first node, will receive 2 additional drives. And my second node will also receive 2 additional drives. And I will also add 2 additional drives to my third node. I have to specify these values here in my script. You can build your own one. You could also have a script that adds 2 drives to each node. This is my script. I'm always updating manually depending on the needs I have, number of drives, things like this. And now I will also execute this one here. Now let's check what happens in our cluster. We already can see additional drives. Here we can see drives that are not in pool. So there's something unknown here with these drives. But when we go to the summary, we can already see 22. Now it's switched from 22 to 24 drives. We added to 4 servers, 2 drives in each, so 8 drives. So we extended from 16 to 24 drives. What happens in the background? Storage Spaces Direct says, okay, before I explain the next steps, let's have a look at this. The new drives have 0% here usage. The existing drives 92%. So what happened? I added drives to my servers, and let's sort here for the servers, or maybe I think we also can group here by an object. Group by, I want to group by server. Now we can see the drives in each server. And we can see in each server, we added 2 drives that are new. And these new drives have been in the first step, they have not been in the pool, but they have been poolable. For a drive, there's a status, it's poolable. So if everything in the drive is compatible with Storage Spaces Direct, it's a poolable drive. And as we have seen on the slides, such a poolable drive will be added to the pool automatically. Now we have the situation, we have additional capacity, but this additional capacity, it seems to be a little bit imbalanced because, let's refresh here, actually we have 90% on the previous drives and 0% usage on the new drives. So let's check for the volumes again. The volumes are still there, they are healthy. We have full redundancy. We don't have any outage here, any loss in data. In the drives, we can see we have additional capacity now. We have the situation that we are out of the reserve here because I added drive capacity to my server. And so I have again the free capacity on each local drive to be able to run a local parallel rebuild. When we go to the inventory, we still can see that there's no data on these new drives. So when we think back to how Storage Spaces Direct distributes the data across the servers, then we can see, yeah, okay, this is possible because when we go one slide back with these copies that are created here by Storage Spaces Direct based on the slabs, then this is okay because if we have in each server a free drive, we can work with this distribution of slabs across the servers. So I can already consume this capacity because I will have no limitation in my redundancy if I consume the new space on exactly this drive. But maybe I will not see the best performance because here we can see Storage Spaces Direct typically does not build the copies across the drives. It distributes it equally across the servers and drives and ensures that we have always the redundancy based on the fault domain, and the default fault domain is the server, the chassis, the server entity itself. And here we can see that we have a rebalancing that automatically starts within 30 minutes after adding the drives. So we have to wait for 30 minutes and then this rebalancing starts in our pool. It's maximum 30 minutes, so it should start within 30 minutes, this rebalancing. that ensures that we use this new drive absolutely optimal. So we will have a rebalancing, a redistribution, an optimizing of the slabs also to these new drives, even if I do not add any new volumes or any new data. With an get storage job, we can see what happens, and with an optimize storage pool and then the friendly name, we could start the optimization now. So let's check on the server what actually happens here. I will leave this page here open and will open a new tab with Windows Admin Center and connect to one of the nodes of my cluster. Let's connect to node 41. I need the credentials again. I want to use the credentials for all connections, and then I'm connecting to this node here. I will open a PowerShell session. We'll authenticate on this machine. And I will use a get minus storage job. Storage job I want to have here. You can see actually no storage jobs are running. So now we could wait these 30 minutes, or I could execute an optimize storage pool with the friendly name of the storage pool. So let's check what's the situation with our storage pool. I will go to the settings of my cluster, and here we have storage spaces and pools. And my storage pool is S2D on and the name of the cluster storage pool on D102 minus Azure Stack HCI cluster 40. In a production environment, I would recommend you to wait because this 30 minutes has a reason. The reason is it ensures that all the drives are added completely to the cluster, that all the value is updated for sure. I have checked via get storage job that there are actually no jobs running with adding disks. In a physical environment, this default time of 30 minutes within 30 minutes ensures that if you are adding drives, let's imagine you add the first 2 drives to the first server. Then you have to go to your service desk and pick up the next 2 drives because they were prepared, they were unboxed or something like this, and then you add them. Then it would not be a good idea if this job starts within 5 minutes, within 2 minutes. Now the question is, what's a good idea? Is it a good idea to start within 10 minutes, in 15 minutes? Microsoft decided for within 30 minutes. And if you are sure that you added all the drives you want to add and you want to start the storage job now, then you can do it via PowerShell, get minus storage job. We can see actually there's no job running. Now we can execute a get minus storage pool. Add storage pool. Now the pool name, it's an S2D on D102 minus Azure Stack HCI cluster 40, and then pipe to optimize minus storage pool. Let's execute this. And now the storage pool optimization starts. And we will also see that here happens something in the drive list, because when we go to the inventory, we'll see that the 90% on the previous old drives decreases and the 0% increases. So we will see something like 60 or 70% at the end on each drive. So, but actually it's still optimizing. Keep in mind, in a production environment, it would be fine to wait for this additional drives to be added. They are added, and then to automatically start the optimization job. So actually we don't see much in this PowerShell where I start the PowerShell. When we go to the disk drives, it's also still the same situation here, but what we can do, we can open another new tab and connect to one of the nodes in our cluster again. I will again use the node 41, but it doesn't matter which node it is. And I can open another PowerShell connection to this node, or another PowerShell session to this node. I will authenticate here. And let's check here for an get minus storage job. And we can see now there's a storage job. This is running on my S2D on D102 Azure Stack HCI cluster. It's an optimized job. Its background is false. Elapsed time is 3 minutes. Actually, it's running. Bytes processed 56 gigabytes. Bytes total 4.13 terabytes. So it will need some additional time to completely rebalance, to completely reorganize, rebalance this extents. Maybe we can already see something here if I really reload this screen here, because 56 gigabytes, the calculator, but I think this should be already some smaller percent numbers. So we will have a look here in a few minutes or seconds. Yeah, let's run another get minus storage job to see what's the actual status. And you can see there is an time already running more than 1 hour, 1 hour 39. It's now 68%. There was some other action. This is the delete option here in object in background. But here we can see we are actually more than 1 hour. And for sure, I had several terabyte size volumes, and it depends on your speed, how long it needs to rebalance these things. When I look at my optimized storage pool, I can see here is now also a progress bar. Before, when we started, it was totally at the beginning, so only one of these circles here. Now it's something like 70% or so, 68% it says here. So I assume that I will have the situation that in after 2 hours or something like this will be finished. And I paused the recording between, because I think it's not so interesting for you to look 2 hours at the progress bar here in the video. So I will pause the video again for a second, and then it will continue when the rebuild has finished. So, and I'm not really pausing the video because what we see is really live. I can execute that again, a get minus storage job. So I will pause the recording to ensure that we save some time in the video you are watching later. Now we can see the job has ended. This get storage pool, pipe optimize storage pool. It's finished, and when we go to the drives, we can see the 24 drives are here. When we look at the inventory, we can see the storage is now equally balanced. So the new drives, previously we had 4 drives in each server node. Now we have 6 drives in each server node. The additional capacity can be used to expand existing volumes or to create new volumes. So this was the scenario of adding drives, but we can also add complete server nodes. Important is to review the hardware requirements. It's similar to what we said about the drives. The new server should be similar to the servers we actually have. It should be the perfect situation is if we have the same CPU, the same amount of memory. It's required to have the same disk layout, number of drives, and type of drives. So we can also add servers with different CPUs. Maybe then we have to choose for CPU compatibility at the virtual machine level if we want to live migrate the machine. And we could add a different amount of memory, but this should only be done if the initial node configuration is not any longer available. It's not best practice when we want to do everything perfectly. So let's have a look in the live demo how the additional nodes can be added, how it works to add additional nodes to the cluster. I will switch again to the live demo environment. Then we'll go to servers. We have our cluster with the 4 servers here, and what I have prepared another server, the D102 Azure Stack HCI 45, and this machine is installed with the Azure Stack HCI operating system. So let's add the server 45. It's the 5th node in this configuration or in this cluster. This is planned here. Found the server. I will add this one here. I have this machine in the list. It's the name. It's the Azure Stack HCI operating system, the version, and now I can add this server to the cluster. Here we can see adding node. Actually, the adding node is in progress, so the node is added to the cluster. And when this has finished, we will see this additional node in our cluster. So actually the node is joining. It's already here, so the node is okay, status is up, everything is fine. The node is joining. Actual model and serial number is unknown because it's not fully joined. Here when we check the progress, we can see it's still adding node to the cluster. And when the node is joined completely, we have the additional server and we have the additional drives of the server. Now we can see this additional server is up. The notification says successfully added nodes to cluster. Let's check the drives. Here we can see now we have 30 drives in total. Previously we had 24 drives after we added 2 drives to each server. The new server already had this disk layout. I added the server node number 5, and this one had already 6 disks that were intended or planned for the pool. I will go to the inventory. In the inventory I can see I have now the server 41, 42, 43. Each server has 6 drives, 44 and 45. Actually, these drives are not in pool. You can see these drives are actually not in pool and the capacity is not consumed. It's similar to the situation we had in the situation when we added disk drives, but we didn't have an additional node. We had the additional drives and it took some while till the pool took the drives and we could see these drives in our pool and use this capacity. When we check via get storage job on one of the nodes, we will see the add physical disk action has been run for these drives. So 6 times, so 6 drives have been added. You can see this via get storage job. And when we go back to our list of the drives, it's refreshed now. Now we can see these drives are okay. So they have been not in pool. Now they have been put to the pool or brought to the pool. And now we have the situation within 30 minutes, the rebalancing will run. It's the similar rebalancing we have seen when we added the disk drives, but now this additional server will be used to rebalance the slabs, the extents, and then we will have after, assume again 1 or 2 hours time, we have to wait here till it's rebalanced on my configuration. It depends on your amount of data. It depends on your performance of your machines. Here in my situation, we have huge volumes created in the demo. I have volumes with a few terabytes here, 4484 terabytes. And remember, we are working in a nested virtualization environment in this demo scenario here. So it really depends on your physical hardware. But I think you have seen how easy it is to add drives to a cluster and to add nodes to a cluster. So I recommend you to test this also in a test or demo environment to get familiar with this progress. And then you must not be afraid if you have such a situation in your cluster or at your customer site.